This is Bob Capetta from the University of Illinois at Chicago, and this is another example of a trigonometric equation. We have sine of 3 theta equals negative 1. We are looking for all values theta between 0 and 2 pi. To help us visualize this, let's think of the unit circle. At 0 radians, the x value is 1, the y value is 0 on the unit circle. The x value is cosine. Cosine of 0 is 1, sine of 0 is 0. At pi over 2 radians, 90 degrees, cosine is 0 and sine is 1. At pi radians, the x value, cosine is negative 1, the y value is 0. And at 3 pi over 2, x value is 0, y value is negative 1. So the sine of 270 degrees is negative 1. The sine of 3 pi over 2 is equal to negative 1. So we're going to use that fact, and that'll enable us to solve for theta. So focusing on that point at 270 degrees, indeed, sine of 270 is negative 1. And the sine of 3 pi over 2 in radians is negative 1. This is our first revolution, our first time around. Sine of 3 pi over 2 is negative 1. So let me go ahead and consider that my first revolution, or revolution 1. But there's another one in revolution 2. If I start at 3 pi over 2 and go around again, namely sine of 3 pi over 2 plus 2 pi, that will also have to have a value of negative 1 because we're in the same location at coterminal angle. How do we add these together? 3 pi times 1 is 3 pi, 2 pi times 2 is 2 pi. 3 pi and 2 pi times 2 is 7 pi over 2. So looking at that then, we can say the sine of 7 pi over 2 is negative 1. Again, one more time on our fraction addition. 3 pi times 1 is 3 pi. 2 pi times 2 is 4 pi. 3 pi plus 4 pi is 7 pi. 2 times 1 is 2. So adding those fractions together, I get sine of 7 pi over 2. That is my second revolution. But how many revolutions do I need? This is telling me sine of 3 theta is negative 1, and I need theta to be between 0 and 2 pi. The indication here is that I'm multiplying by 3, therefore I need to go 3 revolutions to check to make sure I've gotten all of my values. So I need to go one more revolution beyond, so I did 3 pi over 2 plus 2 pi for the second revolution. For the third revolution, I will go 3 pi over 2 plus 4 pi. So let's take a look at that. Revolution 3. Sine of 3 pi over 2 plus 4 pi over 1. And that will also equal negative 1. Now let's think about how we're going to add the fractions here. 3 pi times 1 is 3 pi. 4 pi times 2 is 8 pi. 3 pi plus 8 pi is 11 pi over 2 times 1 is 2. So we get 11 pi over 2 is our answer in the third revolution. So we'll quickly write that. So sine of 11 pi over 2 is also equal to negative 1. That's our third revolution. And we have the number of revolutions matching the multiplier. Now let's go through each of those revolutions and solve for theta. So the question is sine of 3 theta is negative 1. In my first revolution, sine of 3 pi over 2 equals negative 1. So let's think about that now. If sine of 3 theta is negative 1, and sine of 3 pi over 2 is negative 1, that would mean that 3 theta would equal 3 pi over 2. And then if we divide both sides by 3, that would just give me theta is equal to pi over 2. So that's one of our solutions, but not the only solution. So indeed, going through that argument, 3 theta is 3 pi over 2, dividing by 3, theta is going to equal to pi over 2. That's first revolution. Second revolution, sine of 3 theta is negative 1, and sine of 7 pi over 2 is negative 1. So if that's the case, what are we going to have to argue? We'll say 3 theta is equal to 7 pi over 2. Dividing by 3, multiplying by a third, Theta is 7 pi over 6. Still between 0 and 2 pi, which is good. Now let's go to our third revolution. So again, our question is sine of 3 theta is negative 1. And then down here we see sine of 11 pi over 2 is negative 1. So if that's the case, 3 theta is 11 pi over 2. Multiply both sides by a third. So theta is going to be 11 pi over 6. Which you will recognize is still going to be between 0 and 2 pi. But you'll notice 11 pi over 6 is awfully close to 2 pi. If I would have gone to a fourth revolution, when I would have divided by 4, my answer would have been beyond 2 pi. So the number of revolutions you go is typically the same number as the multiplier on theta. So we have three solutions. Theta is pi over 2, theta is 7 pi over 6, and theta is 11 pi over 6. So let's write that as a set using curly braces. So my final solution will be, indeed, pi over 2, 7 pi over 6, and 11 pi over 6. Those are three answers theta between 0 and 2 pi, such that sine of 3 theta equals negative 1. And that will conclude this lesson.